This is our first lecture on special forms. The first thing we'll be doing is factoring perfect square trinomials. So here's our factoring strategy on the left, and just kind of as motivation. So if I was just factoring this the normal way, I have 36x squared plus 60x plus 25. How many combinations of things would I need to try? If I did the AC method, or if I did the guess and check method, AC method and diamond method start out the same, so we'd be looking at the same number of things to try in either case. AC is 900. Those are all the factor pairs of 900, and then I'd need to find some that add to 60. I could do it, it's just a lot of things to go through and check. If I did guess and check, then 25 has fewer factors, so I'd put that in the fixed spot, and then I'd have all of these things to put in the blanks and try. So that's a lot of possibilities to go through. There is an easier way to do this one, so let's look at that. If I look at 36x squared plus 60x plus 25, don't worry about why I'm doing this, just see if it is the same thing. That's the same thing as 6x squared plus 2 times 6x times 5 plus 5 squared. Let's just double check and look at that. 6 squared is 36, x squared is x squared, the first term matches. 2 times 6 is 12, times 5 is 60, so the middle term is 60x, and 5 squared is 25, so that is the same thing. Now if I told you that I had this formula that said if you have something that's a squared plus 2ab plus b squared, it has to be a plus b quantity squared, then we'd automatically be able to factor this. Because a is like 6x, b is like 5, so I do have a squared plus 2ab plus b squared. So that must factor as 6x plus 5 squared. Now most trinomials are not perfect square trinomials, but if we do see one that's a perfect square, it saves us some time by knowing this formula. How can you recognize a perfect square trinomial? Well, the first thing to look for is to see if the ends are perfect squares, to see if the first term is a perfect square, and see if the last term is a perfect square. And in this case they were. 25 is 5 squared, and 36x squared is 6x squared. So in general, if I have a squared plus 2ab plus b squared, I know that's equal to a plus b. If I put a blue circle everywhere there's an a, and I put a red triangle everywhere there's a b, then I would get this formula right here. If you prefer the AB formula, by all means use it. That's totally fine. But there's a lot of people that do like the shapes better. So let's look at x squared plus 18x plus 81. Does this have the chance of being a perfect square trinomial? Well, let's look at the ends. X squared is a perfect square, and 81 is 9 squared, because 9 times 9 is 81. I need to verify that it's real, if the middle term really does fit the form. So x is like x squared, 81 is just 9 squared. I want to see if I have 2 times 1 of each of those in the middle. I have an x squared on the beginning, I have a 9 squared on the end, I want 2 times x times 9 in the middle. Well, 2 times x times 9, that is 18x, so that is a perfect square trinomial, and I know that it factors as x plus 9 squared. I would check it by writing x plus 9 squared as x plus 9 times x plus 9, and FOILing it out. And I do get x squared plus 18x plus 81. Okay, let's look at this one. I know that it might be a perfect square by looking at the ends. 49a squared is a perfect square, and 9b squared is a perfect square. 49a squared is really 7a squared, and 9b squared is really 3b squared. Now I just need to see if I have the right middle term. So wherever there's a blue circle, I put my 7a. Wherever there's a red triangle, I put my 3b. So if that middle term turns out to be 42ab, I'm in business and I can use the formula. Well, 2 times 7 is 14, times 3 is 42, so that is 42ab. So the middle term works, and therefore it factors as, remember, wherever there's a blue circle, you put a 7a. Wherever there's a red triangle, I put a 3b, so it factors as 7a plus 3b squared. And again, I would check that by doing FOIL, and it checks out. Okay, this next one, let's see if it's a perfect square. It might be a perfect square by looking at the ends. The first term is 2w squared. The last term is 3 squared. So if I have 2 times 1 of each of them in the middle, it is a perfect square. So I put a 2w wherever there's a blue circle and a 3 wherever there's a red triangle. Well, that's 12w. That's not 6w. So this isn't a perfect square, and you have to factor it the old way. You'd say it's either 4w and w in the parentheses or 2w and 2w in the parentheses. Of course, this is if you're doing guess and check. List the ways that 9 can go in there. Look at my outside and inside. That one doesn't work. 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 And that one doesn't work. Therefore, this polynomial was actually prime. Now, it might factor the other way. It was just kind of fluky that it was prime. But that's another example of perfect square. Okay, this is another example. Now, don't forget that our factoring strategy always has us look for a greatest common factor. This one doesn't have one. It also doesn't even have a chance of being a perfect square trinomial. So let's just do this one for review. Let's try the AC method this time. A times C is negative 168. Those are all my factors of negative 168. I finally found one that gave me 13. That tells me how to split the middle term. Now I'll do grouping. Factor 2h out of the first pair, I'm left with 7h minus 4. Factor 3 out of the second pair, I'm left with 7h minus 4. So I have 7h minus 4 times 2h plus 3. Okay, for this one, don't forget to write it in descending order. Now this one is very easy to just factor on its own, but it is also a perfect, or it could be a perfect square trinomial. So we'd have y and 1 in the circle and the triangle, and we'd want to see if there's 2 times a circle times a triangle in the middle. And that gives me 2y, so it's really close. Now if you look at the perfect square formula, there's one where the middle term's positive, and there's one where it's negative. If it's negative, I just put a negative in the parentheses. So that is y minus 1 quantity squared. And if I FOIL it, it does work out. I get y squared minus 2y plus 1. Okay, we'll do just a couple more. Is there anything common to these? Yes, there's a p, so I can pull that out. Now, is this possibly a perfect square? Looking at the p squared, that looks like it could be, and the 36q squared. P squared is p squared. 36q squared is 6q squared. Let's see if the middle term matches. 2 times 1 of each of them. That gives me 12pq. So I'm off just by the sign. So I just put the sign in the parentheses. And I don't want to forget my p, my greatest common factor that I pulled out at the very beginning. So my factorization would be p times p minus 6q squared. Okay, is this one a perfect square trinomial? It could be, looking at the ends, because that's 5m squared and that's n squared. Let's see if the middle matches. Put 5m in the first slot and in the second. That would give me 10mn, which matches except it's negative. So I just want to make sure the negative is in my parentheses, and it's 5m minus n squared. And if I FOIL it out, it does work. Okay, looking at this one, it might be a perfect square because that's p squared and 10 squared. Let's see if the middle term works. 2 times p times 10? No, that would give me 20p. That's nowhere near negative 4p, so it's not a perfect square trinomial. I have to go back and do it the old way. So I know it would be p minus, and those are all of my choices. If I look at the outside plus the inside, that pair doesn't work, and this pair doesn't work. That pair doesn't work. This pair doesn't work. And this pair doesn't work. So again, I found one that is prime. Just make sure that you've exhausted all possibilities before you call it prime. Okay, and I think this is our last one. This one could be a perfect square because of the ends. That's a 2w squared and 9 squared. Now we'll check the middle. So 2 times 2 is 4, times 9 is 36. That does match. So it's a perfect square. And I'll put my 2w in the first spot, my 9 in the second, and it's 2w plus 9 quantity squared. FOIL to check your work, and it does work.